I have about 25 slides. Quite a few of them are filler slides, so we rush through. That's, for example, the first filler slide. What we're going to do here in this presentation, talk a bit about background and regulations, in particular to cybersecurity and the history of safety and security in the context of gun and automation. Then a bit about the currently ongoing 5325-5 gun open safety review. Uh, we will look into cybersecurity in embedded systems and basically what we can do, which are currently under development. So the latter one, as in particularly last 2 points, they are brief because that's very much ongoing work. So bit words on my person. I have a degree in physics, so I'm not an electronics engineer. I spent 14 years at CERN in Geneva. I started to work with HTML, for example, in 1993 there. And then, as Rainer mentioned, I was product owner Canopen, embedded control, and later on actually Ethernet IP also for companies in Germany. I thought it's 27 years, it might be 28 years by now with Canon Canopen. So despite being a physicist, technically I worked since 1986 with data acquisition systems and about since the mid 90s with control systems. So background and regulations. So let's start with safety. Work on CANopen or safety for CANopen started with the CiA 304 document, which was published, I think the last edition in 2003. This is withdrawn now, or is withdrawn since actually 2010, when the EN 5325-5 international standard or European standard was introduced. They tend to have always lengthy titles, and I copied a couple of slides or diagrams from that particular documentation. Concerning the Cybersecurity Act, there is an EU regulation since 2019. There's the EU Machinery Act, which is from 2024. Cybersecurity Act, the original, the first document in this area, entered into force in 2019. The main important point was the introduction or a permanent mandate for ENISA, European Union Agency for Cybersecurity, sitting in Athens. And it introduced the uniform European certification framework for industrial communication technology products, services, and processes, and so on. The machine regulation itself from 2023 covers all machines with moving parts, yeah, even partial or subsystems. The only thing that I found a bit puzzling is it excludes transportation. So what would mean to me, it doesn't cover passenger cars or buses or whatever. Yeah, but they are tricky to read, and if you can get all these documents in all sorts of languages from the corresponding EU pages, web pages. It requires protection of persons, domestic animals, so maybe mosquitoes, and property environment. Networks protected against accidental or intentional corruption and refers to the previously mentioned Cybersecurity Act. Oops, sorry, this was a bit too fast. Go back. So you want to go to the Cyber Resilience Act. This entered into force in 2024, and all requirements of the CiA have to be complied with by December 11th next year. There's a statement from the CiA preamble, which basically all products with digital elements integrated or connected to a larger electronic information system can serve as a tech vector for malicious actors. So basically, it sets a scope for it. And it requires you, should therefore consider that you design your products with basically designed and development with regulation in mind. Yeah, so it's covers both design by security and at the end develop. There's one thing, however, that is a bit hard to find in this Cyber Resilience Act. Basically, in Article 14, uh, there are reporting obligations of manufacturers, basically reporting to ENISA that apply from September 11th, 2026. So that's pretty soon. And the date of September 11th actually is not in Article 14, but it's pretty much at the end, just above the signature of Madame Messola. And so you have to search a bit for it. A manufacturer shall notify any actively exploitable vulnerability contained in a product with digital elements that becomes aware of to ENISA, to the agency in Athens. So essentially, you have timeframes from 24 hours. You give a warning, 72 hours for a notification, and 14 days after you fix it, you have to deliver a final report, which a lot of companies say is tricky to handle, particularly small companies. Yeah, when you are a large-scale company or organization, you may be able to do that. However, for small companies, this is certainly a challenge. What can help you there is with the vulnerability reporting. There's forum incident response and security teams, similar actually to CERT, the cybersecurity or cyber emergency response team. And behind this link here, there's a scoring system, a calculator that will help you to do a scoring scale from, I think, 1 to 10. The problem with this is it initially had mostly IoT applications in mind, not necessarily embedded technology as we are talking about here. Yeah. But for that, we try to do some recommendations. It has on this website extensive documentation. So we come to Canopen safety itself a bit. A couple of definitions from the 5325-5 and what is left out, what we figured out recently, and what has been specified since. So since 2010, anyway. So what EN 5325-5 does, it defines a safety-related logical device that uses a communication mechanism which is called safety-related data objects. And this is essentially in parallel to what we have in the classical open world that we know since 1996 or something like that, where you don't take care of safety. The difference is these safety-related data objects, they are transferred basically with certain measures and twice an inverted data and with a certain timing consideration, but over one physical CAN network only. So this uses a wide channel approach. One of the things pretty much at the beginning of this document is essentially it shows relations to other standards. They are so numerous, I must admit I cannot read all of them. There's no way. You will have to find a lot of time for them, yeah, because they are not easy to read either. So what, however, is missing really, there are no definitions of procedures related to safety related logical device definition configuration, and there's no clear definition of safety related state machines. It talks a bit about a working state and a safe state, but how they look like and how you trigger a transition from a working state to a safe state it's indicated in the body text, but it's not formally stated in any state machine diagrams. So the first issue, basically the procedures related to the configuration, we addressed in CiA 319 version 2.0, Canopen implementation and configuration specification for safety-related devices. This contains both definitions for system integrators, how they handle their system and device configuration, but also it includes some definitions or recommendations for specification editors, what they should foresee. For example, if they edit a CANopen safety-related device profile, or even manufacturer-specific stuff. So this document was in the version 2.0 published end of 2025, so end of last year. And we are currently considering to integrate the contents of that either into the specification body or into normative or informative annexes of the next version of the EN 5325-5. So certainly the part, let's see, where's the laser pointer? This part here, specification editors, that's definitely would be definitely an informative annex. If that goes, the definitions for system integrators, so the procedures for system integrators, if that goes into a normative part of the body text or into a normative annex, we are still discussing within the interest group 06, that's functional safety and security, and the special interest group functional safety 601. The state machines, that is something that we seen in a recent discussion of basically the two groups, the 601 and 602 together, because it's no formal definition, and to some extent, currently security is left out, but a lot of people said a security incident may be considered as triggering a safety incident. So when somebody breaches into your system, it can quite well be that your system is not safe anymore. So when you have essentially interconnected mechanisms or interconnected state machines, you rather like to have a formal definition of those. So there's nothing yet. It's explicitly left out, as we'd seen in the previous slide here. So here, this part, the logic device, which would, for example, contain a state machine, is not covered by this document. But when you talk about safety and security together, you may actually want to have that. The SLRDO mechanisms is not formally described with protocol state machines. However, this may not be needed anyway, because the timing consideration are described quite well, and the timing requirements are described quite well. So I have a couple of examples here. When we talk about the SRDOs, so you have application objects, safety-related application objects, you have safety-related communication objects, and then you have your classical stuff from the CANopen world, as you know it from previous SDOs, PDOs, USDOs, sync, NMT, whatever. They use one data link layer only currently, and one physical layer only. So the data link layer is considered a black channel approach. So it's safe. And here we are in the white channel side. So you assume that the underlying communication is safe, protected by CRC and so on. So how does that work? The cyclic transmission, so actually one thing I mentioned here, the SRDOs are both cyclic or event-driven. They can be both cyclic or event-driven. So you have a refresh time within which a safety-related device, a logical device, produces data. It transmits it via CAN to CAN messages via one physical layer. CAN2 is inverted with a offset CAN identifier. So you have essentially two messages and you can compare them to each other. There you have your safety cycle time. So basically a consumer expects within a safety cycle time update, a refresh. And if that update comes too late, then we have the safety cycle time expired, and there's an event then to the logical device, and the logical device shall switch into the safe state. However, the safe state, as we mentioned before, is not part of the EN 5325. It's part of the logical device definition. So we may consider it including it there. So the safety-related validation time. So apart from that, you update your data essentially within a certain time interval, you also make sure that the two messages that you sent, the original one and the inverted one, come within a certain time frame. And if this is not the case, when the second CAN message comes, for example, too late, then again you have the same situation. You signal an event and enter a safe state. So this is actually, it's not formal, but everybody thinks it's actually good enough, the description, so we may not need formal protocol state machines. So coming now to the cybersecurity. So I will talk a bit about the current work. There are quite a few open questions, and actually with relation to the safety stuff, what we do when we have a cybersecurity event and how we handle if the device has also to be safe. So there's another working group within Canon Automation. That's the IG06602. HABLE Cybersecurity is working on a set of recommendations and specifications. First of all, they shall enable device suppliers to address CiA requirements. That's essentially recommendations because some of the documents I cited here, the IEC 62443 series, and particularly part 3-3, has a lengthy table at the end in an annex that defines certain security levels and what kind of measures you have to take and to address when you're designing a secure device. This is lengthy, and yeah, we decided in the group to use this particular series because it essentially addresses industrial communication networks, not IoT, but industrial communication networks specifically. What we have in requirements for our work within this special interest group. First of all, no change in existing protocol specifications for both CIA 301, the original CAN-open specification, and the CIA 1301, the CAN-open FD specification. So this is pretty much a must because that would break too many things. So we cannot add something to the existing protocols because there would be significant consequences. Then the other thing that's not an absolute requirement, but certainly we don't want to reinvent the wheel. So we try to reuse existing security technologies such as TLS, so transport layer security, but we are not sure where to put them. So I will come to that a bit later. Currently, we're working first of all on CAN-open object dictionary entries that enable secure network authentication. So for indication of the device's security functionality, for authentication, and event logging, for example. Yeah. I think I've taken here one as a example. Don't take this particular index too serious currently because it's not that final fix. The document is not published yet. So it's actually not even the work draft phase. It's in the work draft proposal phase. So it would be a record that allows you to do standardized security type capabilities, manufacturer specific and profile specific things. And they can be different for devices, but it allows you to inquire what a particular device in your CAN-open network actually can support. A further topic, this is currently discussed quite actively, is the layering with respect to the open systems interconnection layering. So we have two options on the table. Either we put it as a sublayer in the application layer in between object dictionary entry and the communication service. So in between object dictionary and SDO, USDO, whatever services, or in the application itself. Both have their charm, but this discussion is very active currently. And I think we will have the next session focusing on that. There was a proposal to put it into the application itself about 2 weeks ago. Personally, I was initially skeptical, but now I'm warming up a bit to it. So this is open. The important aspect for both things, and that was the original idea for the first proposal, was you would like to guarantee a data consistency between CanOpen Object Dictionary and the application. So when you think of, for example, an SDO or USDO service, you write something to the object dictionary, and then you figure it out that the security layer in the application doesn't like it. So because the device that originally initiates this transfer or this write request is not authenticated, or some challenge response mechanism fails. Then you have data inconsistency. You have data in the object dictionary and data in the application. They differ. That may cause a problem. This is a discussion in progress. It might be, that's a very vague idea currently, some sort of caching mechanisms that before you actually activate data in your object dictionary that you have been transferred to, you first do a validation process. And when this validation succeeds, then you activate the data in the object dictionary that allows you to keep the data between application and application layer object dictionary consistent. So this is very much work in progress, and there will be, I think, the next 2 months, a lot of discussions on that. So then we come to the topic mentioned earlier. We had discussions in the functional safety and the cybersecurity group in a common meeting in, I think it was in February, where it was first pointed out there's a tendency that in the participants, in the experts, within the experts there, that a security event may actually trigger a safety event, because when somebody breaches in your system, you're not sure what's happening, and when the system has to be safe, you would like to get it into a safe state and fix it first and sort it out first. But currently, as we don't have formal state machines, we may need to have a mechanism to do that. Because currently the EN 5325-5 explicitly states security is not within the scope of this document. But there are, I know at least activities within France that they're working on a document that I think, I'm not quite sure if it will go to IEC or ISO at the end anymore, where both of them will be required in common together to work together. So the other thing that we had in a recent meeting about a few weeks ago, that who's actually controlling a transition into the safe state in case of a security incident? Does it do the device itself, or does it just inform a manager in a safety network that there is something and the manager has to initiate the transition? So that is still open and under discussion. So I hope you don't hear the cavalry currently coming. It's a bakery that's coming here always on Tuesdays. So a summary of my presentation. I kept short. 325 is a review has started. We still have a bit of time to get this thing updated or leave it as it is, but certainly we will have to change something because some of the references in there are not valid anymore. And it is a bit unfortunate. Some documents are referenced that aren't exclusively in German, so that's not good for a lot of people. We collect open questions. We discuss the integration of the CiA 319 document into the EN 5325-5. Cybersecurity will be addressed with recommendations related to the CiA and with specifications. So the objects, for example, will fall under the specification series, and protocol sequences, not protocol changes, only particularly protocol sequences will be covered by the specification documents. And as I mentioned earlier, any changes in current protocols specifications shall be avoided at any cost. So, thank you.